Alright, so let's find all relative extrema using the second derivative test for relative extrema, if applicable. So remember, the second derivative test doesn't always work, right? If you get out 0 for a critical value when you plug it into the second derivative, then remember the test fails. You have to go back and use the first derivative. So let's look at this first one. So f of x equals x to the fourth plus 4x cubed. So remember, first step is always, no matter what, find your domain. In this case, our domain is negative infinity to infinity. So from here, find your critical numbers. So step 1 was domain. Step 2, find critical numbers. So be careful. Usually one of the biggest mistakes I'll see people make at this point is they will try to go ahead and find your possible points of inflection and say those are your critical numbers. Remember, they're not. The critical numbers come from the first derivative, right? So in this case, to find our critical numbers, we need the first derivative, f prime of x, equals 4x cubed plus 12x squared. And so the factored form of that, so that's going to be factor out of 4x squared times x plus 3. So we know we have to find the values where it's undefined and 0. So f prime undefined, never, because it's a polynomial, right? And then f prime equal to 0 means that 4x squared times x plus 3 equals 0. So 4x squared equals 0 means x equals 0. X plus 3 equals 0 means x equals negative 3. So these are our critical numbers. All right, so what the second derivative test asks you to do is plug these critical numbers into the second derivative. And then if the sign of the second derivative is positive, then you have a relative minimum at that critical number. And if the sign of the second derivative is negative when the critical number is plugged in, then the function has a relative max at that critical number. So here we need to find our second derivative. So f double prime of x, in this case it's 12x squared plus 24x. So then plugging our critical numbers in, so f double prime of 0, so that's 12 times 0 squared plus 24 times 0. Well, that's going to give us 0. So the second derivative test fails. So what's that mean? Does that mean there's no extrema there? No. Now you have to go back, use the first derivative test for that critical value. So using the first derivative test, you'll find out that there is no relative extrema whenever x equals 0. Now, I'm not going to write out that work right now, but you can go back, you should go back and do that work. So make sure you go back and do it because you're going to have to do it on the test. So now, on to our second critical number. So f double prime of negative 3. So that's 12 times negative 3 squared plus 24 times negative 3. And we evaluate that out, so you end up getting out 36. So 36 we know is greater than 0, so f has a relative minimum in this case. At the point negative 3, f of negative 3. So remember, you're always finding the point, which in this case is equal to negative 3, negative 27. So remember, how do we get that? So that's just plugging back negative 3 into the original function. So that's negative 3 to the fourth power plus 4 times negative 3 to the third power is how we got the negative 27. And there is no relative max because we already said, and you did the work, that x equaling 0 is not an extrema. And those are our only two critical points. Now, something to keep in mind, we could have used the factored version of the second derivative to test it also. It was easy enough in this one, that's why we didn't. But you could have used the factored version to test. But either way, so we know f is concave up at the critical number when x equals -3. So we know f has the relative minimum there. So that's what's going on. Alright, so let's find relative extrema using the second derivative test if applicable for f of x equals sine x minus 1 on 0 to 2 pi. So I've already restricted your domain for you to 0 to 2 pi. So first thing we need to do is find our critical numbers, right? So to find the critical numbers, well, we need the first derivative, so f prime of x in this case is just cosine x. And so we know f prime is defined on 0 to 2 pi. So we don't get any critical values from there. And so then we just need to set f prime of x equal to 0 on this interval, 0 to 2 pi. So cosine x equals 0. And on 0 to 2 pi, then, that's going to mean x equals to pi over 2 and x equals to 3 pi over 2. So these are our two critical numbers. From here now, so we need the second derivative, so f double prime of x. So f prime was cosine x, f double prime is negative sine x. So whenever x equals pi over 2, f double prime of pi over 2 is negative sine of pi over 2, which is -1. Well, that's less than 0, so relative max. And f double prime of 3 pi over 2 is equal to negative sine of 3 pi over 2, which is equal to the opposite of -1, which is 1, which is greater than 0. So f has a relative minimum. So therefore, by the second derivative test, f has a relative max at the point pi over 2, f of pi over 2, which is equal to pi over 2, 0. And a relative min at 3 pi over 2, f of 3 pi over 2, which is 3 pi over 2, -2 on the interval 0 to 2 pi, because remember, we're only restricting it to 0 to 2 pi.